mynews.studio.
In a quiet lab in Newcastle, scientists have managed something that could change the outlook for families dealing with genetic diseases. The question is, could 3 different sets of DNA really be the key to healthier babies?
It's July 18th, 2025. Let's get into it. The Newcastle Fertility Center has pioneered a mitochondrial donation IVF technique. Can you walk us through what that involves?
The main goal here is to stop mothers from passing on mitochondrial diseases. What the team does is use eggs from both the mother and a healthy donor. Both are fertilized separately with the father's sperm. Then, at the pronuclear stage, that's just before the parent's genetic material fuses, scientists remove the nuclear DNA from both embryos.
Hang on, just to be clear, they actually take the DNA out of each embryo that early?
Yes, exactly. The pronuclei from the parents, which hold almost all the genetic information for the child, are transferred into the donor's embryo. But first, the donor's own pronuclei are removed, so what's left is just the healthy mitochondria from the donor.
So that means the embryo ends up with nuclear DNA from the parents and mitochondrial DNA from the donor. Is that where the term three-parent babies comes from?
That's right, although the phrase three-parent can be misleading. The donor's role is limited to providing mitochondria. Mitochondria are vital for energy production in cells, but they don't affect things like eye color or personality.
And what about the outcomes so far? How have the children born from this procedure been doing?
So far, 8 babies have been born in the UK using this approach. All of them are in a structured follow-up program. 5 haven't had any medical issues. 3 did face some early health problems, but none of those were linked to the mitochondrial donation. In most cases, mutated mitochondrial DNA was undetectable or well below the level that would cause disease.
How do researchers actually keep track of the children's health over the years?
They've set up a structured follow-up program. The children have regular medical checkups, developmental screenings, and tests for signs of mitochondrial disease. The Newcastle team also publishes their findings, so the process stays transparent and others can learn from it.
But if the method works, why isn't it available everywhere? What's holding back other countries?
Mostly, it's about ethics and regulation. A lot of countries ban altering human embryos or mixing genetic material from more than 2 people. There are concerns about long-term safety, unforeseen effects, and even fears that it could lead to genetic enhancement.
The UK gave the green light back in 2015, after a public consultation and scientific review. Has that decision influenced other countries at all?
There's been some movement, but it's slow. A few policymakers are open to re-examining the rules as more safety data comes in. But most countries, including the US and much of Europe, still haven't approved it. The debate is ongoing. The question is, how much evidence is enough to shift policy?
And mitochondrial diseases affect millions worldwide, right? So if this becomes more accepted, the impact could be significant.
That's exactly it. It's not just about individual families. It's about how society chooses to deal with inherited diseases. This technology could change reproductive medicine and help reduce genetic disorders overall.
But there's still the question of long-term effects. Even if the first 8 children are healthy, what happens in another 10 or 20 years?
That's why the long-term monitoring matters so much. Publishing ongoing data is essential, not just for building trust, but for shaping future policy.
And the ethical debate isn't just about science. It's also about the kind of choices we want to make for future generations.
It really is a crossroads for medicine, policy, and ethics. The technology is already here. How we use it is still an open question.
It's striking. The science advances quickly, but the questions it raises might take much longer to answer.
Exactly. For now, there are 8 healthy babies and a new direction in medicine.
That wraps up our look at mitochondrial donation IVF, a story where science, ethics, and policy meet.
Thanks for joining us. This episode was brought to you by mynews.studio. You can try it now for free.